Okay, here the recording in progress. All right, so we are over here. I'm starting 4.8. So I was pretty much done with 4.7. So I'll do 4.8 today and tomorrow. Tomorrow you get a quiz. And then I think we'll have plenty of time. We still have 4.9 to do. Even if I take until Monday to finish 4.8, I still have Tuesday, Wednesday, Thursday for 4.9. Okay, so quiz tomorrow, but next Friday, the 5th of November will be exam 4. Okay, after which we only have 2 small chapters left. Chapter 5 is only 3 sections, and chapter 6 there's only 4 sections that we're scheduled to do. Okay, so the semester is winding down pretty rapidly, actually. Okay. All right, so without further ado, let's get started on 4.8, which is on the inverse trig functions. Now, we talked about inverse functions before, so we now have inverse trig functions, 4.8, page 251. And let me go ahead and show you what the problems are for those who don't have the book and aren't getting it. So let's see, we had to do 1 to 45 odd from 4.8. So that fits all on one page, I think. So here we go. There's a lot of arc stuff, ARC, but sometimes written with a -1. It looks like a -1 exponent. I'll be using both notations. 3, I need to go to 45, so it's 45. There we go. It's 45. Okay. So we're all there. Okay, first recall some properties of inverse functions. You can have an inverse of a 1-to-1 function, passes both the horizontal and vertical line test. The inverse function is unique. There's only one such inverse, F inverse. The domain of F inverse is the range of F and vice versa. That makes sense because we were swapping the X and Y coordinates. So the domain of one becomes the range of the other. Okay, F inverse of X equals Y means the same thing as F of Y equals X. You just switch around the X and Y for F and F inverse. And if you compose a function with its inverse, you get back the original X. So F of F inverse of X is X. F inverse of F of X is also X. And you might recall we said the graph of the inverse function is a reflection across the line Y equals X of the original F. Okay. So these are the properties of inverse functions. And now where you go. Okay, now you might recall for an inverse function, you have to have a 1-to-1 function. Let's take a look at the sine function. Well, the sine function is certainly not 1-to-1, does not pass the horizontal line test. But if we limit the domain, we do get a 1-to-1 function. Okay, so how do I limit the domain? Well, if I'm willing to only go from -π/2 to π/2, only from there to there, namely over here, then we do have a 1-to-1 function. And therefore it will have an inverse. Okay, so if I'm willing to only talk about sine between -π/2 and π/2, there is going to be an inverse function. Arc sine. So here's some properties of the arc sine. You're welcome to put this on your cheat sheet if you wish. So arc sine has domain -1, 1 inclusive, and range -π/2, π/2. The definition of arc sine, sometimes written as inverse sine, sine with a -1 on top. Arc sine of X equals Y, if and only if sine of Y equals X. Okay, so you just switch around sine, arc sine X equals Y, switch it around, sine Y equals X. If X lies between -1 and 1, sine of arc sine of X is X. If X is between -π/2 and π/2, arc sine of X equals X. Okay. You do have to follow this though. So it's not as obvious. Some of the homework problems, you just look at it and say, oh yeah, sine, arc, sine, they cancel out or whatever. You have to be careful that you're in the correct domain or range, okay, that all of these are satisfied. You don't have to worry about the graph of arc sine, but here it is. Okay, so sine between negative pi over 2 and pi over 2 looks like that. If you reflect across a line y equals x, it looks like that. Somewhat similar. Okay, so just to show you the graph exists, but don't worry too much about it. All right, arc cosine, page 253. Now, cosine, once again, not one-to-one. But if I restrict the domain, it is one-to-one. Okay, so I get the whole graph if I only look between here and here, between 0 and pi. Then I do see a one-to-one function. Okay. This is what the inverse cosine looks like. You don't really have to worry about it. It's not that important. This time, however, we're going between 0 and pi over 2. So for the arc cosine function or inverse cosine, the domain is negative 1-to-1. The range is 0 to pi. You're looking for an angle between 0 and pi for the arc cosine function. Okay, so arc cosine or inverse cosine of x equals y means the same thing as cosine y equals x, provided these hold. Okay, if x is between negative 1 and 1, cosine of arc cosine of x is x. And if x is between 0 and pi, arc cosine of cosine x is x. So key thing to notice, put this on your formula sheet. When you're doing the arc sine function, the thing that comes back is an angle between negative pi over 2 and pi over 2, inclusive. For arc cosine, the angle that you're coming back with is between 0 and pi. Right? Again, don't worry too much about the graph. Here is the graph, but you're not really going to worry about it too much. And when you get to calculus, you're hardly ever going to need the graph of arc cosine either. Okay, arc tangent, however, for some strange reason, does come up quite a bit in calculus. So it is worth it when you get to calculus and know something about the graph of arc tangent. Don't worry about it right now. But okay, so page 255. Here is tangent. Once again, it's not 1-to-1. But if I restrict the domain to just between negative pi over 2 and pi over 2, see that one branch right there, one period, I do get a 1-to-1 function. If I reflect across the line y equals x, it looks like this. Okay, so here's the arc tangent function. Okay, you don't have to worry about the graph too much now, but when you get to calculus, your calculus teacher will talk more about it, no doubt. But arc tangent looks like this. The domain is all real numbers. The range is between negative pi over 2 and pi over 2. Because, flip it around, the domain of the tangent function for which we're considering is negative pi over 2 to pi over 2. And the range is all real numbers. So you just switch around the domain and range, and it looks like that. Okay, so arc tangent, the domain is all real numbers. The range is negative pi over 2 to pi over 2, not including negative pi over 2 and pi over 2. That's different than the arc sine. Arc sine comes back with an angle between negative pi over 2 and pi over 2 inclusive. Okay. So in other words, you could reach the endpoints. Not for the arc tangent, it's parentheses, negative pi over 2, pi over 2. Okay. Arc tangent of x equals y means tangent of y is x. Okay. So when you do arc tangent, the angle that comes back is between negative pi over 2 and pi over 2. And again, this is always true. You can put this on your cheat sheet if you want. X is any real number. Tangent of arc tangent of x is x. This you have to be a little bit careful. X has to be between negative pi over 2 and pi over 2. Then arc tangent of the tangent of x is equal to x. Okay. All right. Those are the main things that you want here. And now, how do you do this stuff? Okay, so find the exact value of the quantity or explain why it's undefined. Okay, There is arcsecant, arccosecant, and arccotangent. We're not going to look at it that much. I mean, just to mention that they're there, but to handle arcsecant, cosecant, and cotangent, we'll go in terms of the reciprocal function. In other words, we'll change it to sine, cosine, and tangent because we don't like them that much. Okay, so I'll just reference that they do exist. The text goes over, whoops, a big deal about arcsecant. I would say don't even worry about it. Okay. And other functions. Okay, so let me start doing some of the problems that are here. You're kind of almost going backwards. You're saying, what angle is there whose cosine, sine, whatever, turn out to be the number that's in parentheses? Okay, so I'll show you what I mean. All right, first, yeah, my own spiel on what's happening. Y equals arc sine x. You can also write it like this, inverse sine of x. That's the way most calculators have it. Okay, some calculators say arc, but some will say inverse sine, sine with a -1, cosine with a -1, tangent with a -1. You have to hit the second function for that, right? So arc sine, inverse sine means the same thing. Arc cosine, inverse cosine, arc tangent, inverse tangent. Okay, so arc sine means the same thing as y equals inverse sine of x. Okay. Caution, inverse sine of x does not mean 1 over sine of x. So that -1 doesn't mean reciprocal anymore. It's an inverse function. In fact, we already have a name for reciprocal of the sine, that's cosecant, right? And what does y equals arc sine x mean? It means sine of y equals x. Okay. But the angle has to be between -π/2 and π/2. Otherwise, you'd have infinitely many numbers at work and you would not have a function anymore. Okay. So yeah, here we are. Y equals arc sine of x or inverse sine of x means sine of y is x and the angle is between -π/2 and π/2 inclusive. And you're welcome to put this on your formula sheet if you wish. Y equals arc cosine of x or inverse cosine of x, these mean the same thing, means you just switch around x and y. Cosine of y equals x and the angle is between 0 and pi inclusive. And then arctangent, y equals arctangent of x or inverse tangent of x, like this, means tangent of y equals x. Again, you switch around the x and y. And the angle is between -π/2 and π/2. Please notice you're not including -π/2 and π/2 here. You are including -π/2 and π/2 here. So non-inclusive here. There's a good reason for that, because the tangent is not even defined at π/2 or -π/2. Okay. We're sort of looking for the quote-unquote nice angle, so to speak. All right, so let me try to do some of the problems. Okay, arc cosine of radical 3/2 was question 1. Arc cosine of radical 3/2. Right? So I would immediately change it from the arc function to just a regular trig function, meaning arc cosine of radical 3/2. Call it theta. Then I would say rewrite this equation so it doesn't say arc. It's just regular cosine. So how do I do that? So here's one way you can reason it out. Okay. Do you think I'm taking the cosine of radical 3/2? No, that doesn't make sense because I'm taking arc cosine of radical 3/2. So if I'm taking arc cosine of radical 3/2, it doesn't make sense for it to mean the same thing as cosine of radical 3/2. I must be taking the cosine of something else. What else is there in this equation? Theta, right? So there's not really much of a mystery if you think of it, if you reason it out that way, that arc cosine can't possibly mean the same thing as cosine. So I must be taking the cosine of theta. Cosine of theta is radical 3/2. All right, so what angle is like that? Cosine means x coordinate. X coordinate is radical 3/2. Well, I know radical 3/2 is always paired with a half. So in my mind, I think sine of theta is a half. Okay, so I go halfway up the circle for y coordinate, go like so, and that looks like 30 degrees. So theta is pi over 6. Okay, so it's the one and only one angle, which makes this a true statement. Okay. Now, there is another angle where cosine of theta is radical 3 over 2. That's down here. But if you're between 0 and pi, which is the reason it was defined that way, there is only going to be one angle, that angle being pi over 6. Here's number 3. Arc sine of 1 is all it says. Arc sine of 1. So I'll just call it theta. Theta. Rewrite it without the arc. Sine of theta equals 1. Again, that should not be a mystery. So I'm taking a sine of something. What I'm going to take the sine of, well, there's only two choices. I'm either taking the sine of 1 or the sine of theta. Does it make sense to take the sine of 1? Well, no, I'm taking the arc sine of 1. So it can't possibly mean that if I have arc sine of 1, it can't mean the same thing as sine of 1. I must be taking the sine of something else. Well, what's that something else? The only thing else is theta. So sine of theta equals 1. Right. So the sine of what angle is 1? Y coordinate is 1. Well, that's pi over 2. So the answer is pi over 2. Now, you might say, wait a minute, I can go all the way around the circle and then come here. That would be 5 pi over 2. I can go around again, 9 pi over 2. I can even go backwards, negative 3 pi over 2. Yes, that's the reason why we insist that for arc sine, the angle has to be between negative pi over 2 and pi over 2. So if we're only allowed an answer between negative pi over 2 and pi over 2 inclusive, there's only one such angle, that's pi over 2. So that way you don't have to talk about, oh, go around the circle, 5 pi over 2, 9 pi over 2, and negative 3 pi over 2, and go backwards again, and so on. There's only going to be one such angle. Okay. It's kind of interesting. Okay, 7's a little bit tricky. Let me show you how to tackle this one. Arctangent of radical 3. By the way, these problems, in theory, should all be done without a calculator. You should be able to do them without a calculator. And I'll show you how they're done. Okay, so it's asking for arctan of radical 3. So that's not something I normally memorize, and that's something I don't memorize either. Okay. So first unscramble it, call it theta. Rewrite it so it doesn't say arc, just tangent. Does it make sense if I'm taking a tangent of radical 3? No, I'm taking the arctangent of radical 3. I must be taking a tangent of something else. Theta. Tangent theta equals radical 3. All right, so here's the tricky play. Tangent is sine over cosine, but sine of theta over cosine theta is radical 3 over 1. And then divide top and bottom by 2, like this. Why? It works. Just go ahead with it, and it works. So now I see sine of theta is radical 3 over 2, and cosine of theta is a half. Okay, we're probably more comfortable with a half. Cosine theta, x coordinate, is a half, so I go halfway across the circle, draw that angle and this angle, but we only want the first quadrant angle. It looks like pi over 3. So theta is pi over 3. So final answer to arctangent of radical 3 is pi over 3. A quick double check. Tangent is sine over cosine. Sine of pi over 3 is radical 3 over 2. That's correct. Cosine of pi over 3 is a half. So when I take the ratio, I do get radical 3. So it works. Okay, 11, arc secant. So here's one case where you have an arc secant, cosecant, cotangent. And we're not going to do too many of them, but the idea behind this kind of problem is to change it into one of the three favorite trig functions, sine, cosine, or tangent. So the original problem says arcsecant radical 2. Let's see, that's problem number 11. Yeah, arcsecant radical 2. So again, call it theta. Rewrite it without the arc. Secant theta is radical 2. I don't like secant. Take the reciprocal. Flip them both. Reciprocal of the secant, cosine. Reciprocal of radical 2 is 1 over radical 2, but that's more commonly written as radical 2 over 2. If you rationalize the denominator, right? Remember going stuff like this. Radical 2, get radical 2 over 2. And then I recognize, oh yeah, cosine of what angle is radical 2 over 2? Pi over 4. So the answer is pi over 4. Now, there are other angles which makes this true. But there's only one angle between 0 and pi that makes that true. That's pi over 4. So that's the reason why we restrict the possible answers to be between 0 and pi. 0 and pi. Okay. Next ones are a little bit harder. You do have to think about it a little bit. Tangent of arc sine radical 3 over 2. I'll call that theta. So ultimately, I'm trying to find the tangent of theta. So theta is arc sine radical 3 over 2. That means sine of theta is radical 3 over 2. I know radical 3 over 2 is always paired with a half, so cosine of theta is a half. So I want the x-coordinate to be a half. I've already seen that before, so that looks like pi over 3. But in any event, tangent of theta is sine theta over cosine theta. So sine of theta is radical 3 over 2. Cosine of theta is a half. Cancel the 2's. Final answer is radical 3. Okay, let's see. 21 and 23 are very instructive because they're not as trivial as you might think. You have to be careful a little bit. 21, arc sine sine. So you might think, oh, just cancel out the arc sine and sine. The answer is negative pi over 4. Well, we've got to be a little bit careful. Likewise, for 23, arc cosine negative pi over 4. You might just say, oh, cancel everything out, negative pi over 4. Not so fast. We have to watch out a little bit. So let's actually work them both out. Okay, sine of negative pi over 4 is negative radical 2 over 2. Because you're saying the sine of what angle is negative radical 2 over 2? That's negative pi over 4. Okay. Arc sine does come back with an angle between negative pi over 2 and pi over 2. Negative pi over 4 is in there. So yes, this one is a case where right away I can just say that theta is negative pi over 4, which happens to match what I have right here. Because again, inside here is negative radical 2 over 2. I'm saying what angle between negative pi over 2 and pi over 2 is there so that the sine of that angle is negative radical 2 over 2. That's negative pi over 4, negative 45 degrees. Okay. So this is negative radical 2 over 2. What's the arc sine of negative radical 2 over 2? Well, back to negative pi over 4. (23), however, is not that nice. Arc cosine negative pi over 4. That's a little bit tricky. So you might just say, oh yeah, negative pi over 4. Not so in this case. First, let's find the cosine of negative pi over 4. Cosine of negative 45 degrees. The x-coordinate, right? X-coordinate is radical 2 over 2. So this thing right here is radical 2 over 2. So arc cosine of radical 2 over 2 is theta. So now I'm saying the cosine of what angle is radical 2 over 2, and that angle has to be between 0 and pi, which this was not. So I cannot use negative pi over 4 as my solution. So what angle is there between 0 and pi? So that the cosine of the angle is radical 2 over 2. It's positive pi over 4. So the final answer is just theta equals pi over 4, not negative pi over 4. So you do have to be a little bit careful. So for 21, it was just the matter of, oh, I can just cancel these out, negative pi over 4. But we have to analyze that just to be sure. For 23, after the analysis, the answer was not negative pi over 4. It actually comes out to be positive pi over 4. Okay. So a little bit tricky in that respect. All right. Yeah, I was just about done. Not going to go too much longer. Let me see what else did I want to do. That. .025. Yeah. Arctan tan pi over 3. Okay. Let's actually work it out. Tangent of pi over 3. Sine over cosine. So the ordered pair is 1/2 comma radical 3 over 2. Sine over cosine is radical 3 over 2 divided by 1/2, which is radical 3. So this thing comes out to be radical 3. Tangent pi over 3 is sine of pi over 3 over cosine pi over 3. Radical 3 over 2 divided by 1/2, radical 3. So now I want the arctan of radical 3. The answer has to be between negative pi over 2 and pi over 2. This is already between negative pi over 2 and pi over 2. So yes, the answer is just as simple as pi over 3. Now, if you just had this, so we kind of knew ahead of time it was going to be pi over 3 based on what we saw here. If you didn't know that, you could get the analysis as follows. So let me show you what happens if you analyze it like this. I do see something in the chat, so I'll get to that also. So suppose you just have to find arctangent of radical 3, like that. Okay. So tangent of theta is radical 3. Tangent is sine over cosine, radical 3 over 1. And then the trick is to divide top and bottom by 2. So we've played that game before. So that means sine of theta is radical 3 over 2. Cosine of theta is 1/2. Saying, x coordinate is 1/2. And what angle does that look like? 60 degrees or pi over 3. Okay, so it does look like it works out to be the way I want it to be. Okay, so that was all I was going to do right now. It looks like there's a question in the chat. I was going to maybe save it for tomorrow, but let me check the chat offhand. 4.7, number 33. Okay, let me see if I'm going to do 4.733. An identity. Okay, I think I can do that. $4.733. Verify the identity. Okay, tan x minus cotangent x is -2 cotangent 2x. Okay, tan x minus cotangent x equals -2 times what? Cotangent 2x. Okay, draw my barrier. All right, so what am I going to do? I'll change that to sine and cosine. So sine x over cosine x minus cosine x over sine x. Get a common denominator. So sine x cosine x cosine x. So this is sine squared x minus cosine squared x divided by sine x cosine x. Okay. And let me work on this side. -2 cosine 2x over sine 2x. Yeah, so it's almost like I make this look like this. I have an identity for sine of 2x is 2 sine x cosine x. So I'll multiply top and bottom of this side by 2. And this is not really, it's not cheating. You're just peeking at the other side so you can see where you're headed. And then if I multiply top and bottom, sorry, multiply this by -1 times -1, it's going to look like this. -2 cosine squared x minus sine squared x over 2 sine x cosine x. Okay, so a little timeout. From algebra, remember the opposite of A minus B is B minus A. I'm using that over here. I'll turn these two guys around, cosine squared x minus sine squared x, and put a negative in front of here. Okay, what do I do that for? Because I now recognize this is the formula for cosine of 2x. This is the formula for sine of 2x, and I'm done. So -2 cosine 2x over sine 2x. And there we are, they're equal to each other. Okay, so it's kind of a weird way around it, but it does work. Okay. All right, so I think I'm done for the day, folks. What time is it? So it's 15 minutes. Okay, so let me check the chat. All right, any other questions? Otherwise, I'll continue tomorrow. And tomorrow we'll get a quiz on more trig stuff from the previous days. Okay. Any other questions?
On the right side, how did you get a 2 on the denominator for sine 2x?
Okay, let me go back to that. Okay, where are we now?
The denominator sine 2x on the right side?
On the right side?
Yeah, how did you get the 2 on the bottom?
This 2 right here?
Yeah.
Okay, this is an identity. Sine of 2x is equal to 2 sine x cosine x. So this, let me pick colors. All of this is the same as all of that. Let's see if I can find that for you. That was one of the double angle formulas. Yeah, it's on page 244. Where sine of 2x equals 2 sine x cosine x.
Thank you.
You're welcome. So I just forced it. I knew I needed to have that. So I look at this and say, hey, there's no 2 there. I just put in a 2 on the bottom and then put another 2 on the top. Okay. All right, any other questions, please? All right, that'll do it for today, folks. So have a good day. We'll see you tomorrow. and quiz tomorrow also. Okay, bye, everybody.